All right, so the goal here is to give you an idea of what the Project Veraison is and what it provides, and possibly, well, actually, one of the main goals for me is tell you how you could make use of it and possibly contribute also back into the project. Next, please. I starting off with a bunch of trivia. Just to set the scene, so we have a logo. You can see those colorful ovals are supposed to be grapes. And in fact, Veraison is a term used in winemaking. It's the onset of the ripening of the grapes. And the definition of Veraison is change of colors of the grape berries. So when is the point in time when berries start changing their colors, and then can be many different colors. This is supposed to be, a visual metaphor of the fuzzy nature of trust, which can be green, all good, or red, or anything in between, actually. That's the concept that the logo represents. It's not very fancy, but the concept is strong, so we want to keep it. There is some debate about the pronunciation of the project, so you have options. The original way should be French, and it's Veraison. But if you're not at ease with the guttural R, Veraison or Veraison are also popular. But please do not spell it like the North American wireless network provider, because that would be not good. So next, please. Or maybe I could say something more on the history of the thing. So we started Veraison at ARM because there was this early realization that one can build all the fancy attestation technology on the device side, but that would be useless unless you also have a verifier. Since in remote attestation, the trust between the device and its relying parties is transitive through the verifier, which can be either a third party or a first party, it doesn't matter. But the logic needs to be there to close the trust establishment circuit and connect the relying party to the attester. So we need a verifier, and so we started this project, which was incubated in ARM ATG, the group I was at the time. And subsequently, we decided to donate the project to the Confidential Computing Consortium, which is a Linux Foundation project, which is entirely concerned with confidential computing. And of course, attestation as a fundamental primitive of confidential computing. And by the way, at CCC, we do have a dedicated SIG on attestation with bi-weekly meetings and a few interesting projects there. So Usama mentioned the fact that, for example, we incubated the attested TLS stuff in there, all the work, both the formal proofs and the prototyping of the code that then was at the inception of the SEAT working group in the ATF. And other projects as well. So I think I would suggest you to join that call. There's a lot of people that you've seen at this workshop all the time, and there's good discussion there, and you can bring your topics if you need to. So this slide with pointers, when the slide is shared, you can click on those and jump to the relevant pages. The first one is the place where we have all the repositories, so all the source code is there under the GitHub org Veraison. We have a Zulip chat that you can join if you have questions of any kind. We have a mailing list, which is a bit cricket land, but sometimes something pops up there, which is very interesting. Last year, there was some people from Japan extending Opti with a Veraison client, which was surprising, but very, very interesting. The book is a single place where you can, we have collected all the information that is scattered across all the repositories into a single place, and it's probably a good place where to start if you want to have an idea of what the various pieces are in natural language. And we also have a weekly meeting on Tuesdays, 4 p.m. GMT, if I remember correctly, that you can join, and well, where we have chats and about the project and the ongoing efforts, and then we synchronize on the various aspects. Next, please. What we provide. Okay, so what Veraison provides is an open platform to experiment with the RAS architecture and all the emerging standards that are attached to that. Open in the sense that it is open source. All the code is under Apache 2 license, and open governance in the sense that the backlog is not defined by anyone except who participates into the project. So if you want to bring your own tasks to the project, you are free to come to the weekly and you know, present them and then raise bugs and whatnot. What we provide in terms of code is, I would say, three different things. One is the standalone components, so libraries in various languages, including Golang, Rust, C, Python, that provide implementation for the RADS data formats, CoServe, Corem, EAT, COTS, we have EAR, we have all of them. A bunch of APIs that are built, that we tend to build on top of the reference interaction models that Hank and Ned presented before, which are REST API normally, well-documented REST API with Open API spec, and a bunch of emulators so that you can pull together a bunch of pieces and implement an end-to-end, basically, without having to deal with the real, say, attesters or stuff like that. So this is the first thing. So these blocks, these building blocks. Then we have a reference extensible verifier in 2-3 incarnation. One is the verifier as a service, so a third party. And other two are the verifier as a library. So first party that you can integrate with your relying party to create verifying relying parties. And third, something that has been started recently with in an effort concerted with Google and Oracle, is a reference extensible composite attester, which we call RADSD, which aims to be a system daemon that is standard for, you know, at least Linux distributions that presents a lead attester. I will talk about this later on in the presentation. Next, please. So yes, this is the RAS architecture that you've seen already 2 or 3 times already. The important thing is how the Veraison implements this RAS architecture. So next, please. This is the instantiation. Maybe it's not very visible, but the conceptual messages are replaced with the exact data format that we implement: Corem, COTS, CoServe, EAT, various EAT profiles, CMW, EAR, and so on and so forth. There's a bunch of emulator and command line interface tools that act as emulator. We have what, the key broker is an end-to-end demo in Rust that integrates the Veraison services together with the key release protocol to implement an end-to-end flow based on attestation, right? Where the attestation result is used as to unlock an authorization policy that gives a key to an attester if the attester presents itself with, attests itself with the right evidence. At the center there's services, but there are also 2 other pieces here. One is Cover, which is the Corem verifier, And the other one is a Rust CCA token, which is a library that does appraisal and verification of CCA evidence, which can be linked to applications. Next, please. I will dig into the services first, I think. Yes, this is the software architecture of the Veraison services component. Well, you have the API all around, which are the endpoints through which you interact with the core of the service, which is the Veraison Trusted Service, the TCB of the verification engine, which includes, which has all the logics for the verification plus handles, keys, the stores, all the important objects that are relevant to the appraisal process. Basically, the idea is, and then you have the Andres interface, which basically hides a multitude of technology-specific plugins, which are used to customize the vanilla pipelines that the VTIS service exposes to each of the API. Basically, let's make the example of a verification request. You would hit the verification API. The verification API would do the HTTP dance and then forward the evidence to VTIS through a gRPC channel, which is mutually authenticated between the two guys there. And VTIS would take care of the various stages, right? Verifying the thing, checking the reference values, then enriching the appraisal claim set with endorsed values, then passing it on to the policy evaluation, and then to the final stage of producing the attestation results, which are signed and sent back to the verification API service endpoint. What happens is that at precise point in this stock pipeline, you have hooks that a technology-specific plugin can intercept to provide its own logics to customize the actual process. For example, the way that the key for the lookup of the reference value is created based on the evidence input is computed by the plugin. Specifics about the lookup of the trust anchor that verifies the crypto are done within the plugin, etc. So we do have already plugins for various EAT profiles, including CCA, ARM, PSA, DICE, TPM. We have an incoming AMD, SV, SNP contributed by Oracle. I think we do have an Intel TDX as well in the pipeline, also contributed by Oracle. So those dots are exactly the places where you would contribute your technology. I know that I heard before from Jeremy that GP has their own EAT profile. I think those ... would be the place where you contribute the actual parser for your profile. And implementing that parser would be predicated on the fact that the EAT package has the extensions that you're using. So you probably need to, if you're using extensions to EAT, you probably need to also extend the Veraison EAT package in order to use them. Yes, next, please. Unless there are questions, because yes, any clarifying question can be asked whenever you want. But let me move forward with RATSD. RATSD is this standard system daemon for providing a lead attester to Linux distributions. The architecture is very similar to the service in the sense that we have a set of APIs that are well-defined and implemented as separate endpoints. One is the challenge response API to actually request evidence from the lead attester, and the other is the discovery API to understand what the topology, the underlying topology is, in the sense of which subcomponents are there and how are they related to each other. And then the requests are intercepted by the RAS daemon, the lead verifier logics, which is common, and then dispatched through the attester interface to the specific technology-specific plugins. For example, for Linux confidential computing, we have the config FSTSM interface, but there's also TPM and any other, right? PSA, for example, would be a very good example of another technology that you would put in there. And when the actual sub-evidence are collected from all the plugins that are active for that instance of RATSD, RATSD will take them, package them into a CMW and sign the thing back to the requester. Next, please. So yeah, that's the message. Bring your own attestation technology to the party, and we are more than happy to upstream any feature you might want to use, because the plugin architecture allows you to contribute to your logic without having to touch the core. So it's a very safe contribution model. Next, please. So yeah, I wanted to work through a bit of the work in progress we have at the moment. Next, please. So we are full on with CoServe. We want to provide a full implementation both on the Golang code base and the RAS code base. We now have completed the pipeline in Go with the data model and the server API. And we are working with Fujitsu on the client API and the data model. I think the data model is in much better shape than the client API at this point in time, but they are both bound to be completed in a short time. We are on it. And this would be a full implementation of version 2 of Draft CoServe. So the latest and greatest. Next, please. Another big point here is Quorum. So we're very closely tracking Quorum. We have done a couple of things that are pretty interesting. One is the implementation of section 9 of the draft. So the quorum verifier, right? The deterministic engine that takes quorums and an internal representation of evidence and produces a given accepted claim set that then can be passed on to the subsequent appraisal stages like policy evaluation and attestation results packaging and so on and so forth. Mostly we did this as an exercise to test that the spec was actually implementable, and in the process, which took some time, we discovered that yes, it is implementable, but there are some caveats and some potential confusions here and there. So we've raised also sent a bunch of comments to the RAS mailing list saying so providing suggestion on how to fix to better the section 9. And another thing that we are working on at the moment is the quorum store. So if you go back to the services slide, there was a store bin on the right-hand side, and that is implemented as a key-val store at the moment, and has always been like that because we wanted to be agnostic towards the specific endorsement and ref values format. We didn't want to make any assumption on quorum, but the reality is that after 4 or 5 years, quorum has become a de facto standard. And the fact that CoServe is also reusing the data model and is putting on top of that a query language made us rethink the assumption that we wanted to have, and wanted to keep the key-val store, the simplicity of the key-val store, the agnosticity of the key-val store, and instead reprogram the storing logic in terms of relational tables that are more suitable for querying quorum data sets from multiple angles. So that's the effort that is ongoing at this point in time. We have a gigantic PR, which is under review. But yeah. Next, please. And then going back, touch basing on what Yogesh was presenting in the previous slide deck, which was sort of the theoretical set of assumptions on which we are now, that I'm now describing the implementations of. In this composite world, we have to deal with data models, and therefore we support fully CMW and ER. CMW and I think the Golang and Rust implementation that are listed there are on par with the latest and greatest. We also have a we have a Python implementation, sorry, or not. No, we don't have nothing. No, sorry. We only have those two. It's here that we have in multiple languages, not just the Golang and Rust, but also the C and a Python implementation. So we're tracking the spec, and sometimes we are also a bit further experimenting features, but that's our contribution to the composite world. Next, please. So this is from the data models perspective, from the point of view of the hierarchical pattern that Yogesh was describing before, where you have a lead verifier that basically breaks down a composite evidence and then dispatches the individual pieces to downstream verifiers. This is what we're doing. This is the high-level design of the thing. I've just started coding it last week, so it's a very, very early stage. There's nothing published. I've not pushed any branch anywhere. It's on my desktop. But this is the actual picture. There's a REST API which reuses completely identical the verification API that is used for the single evidence. So from the point of view of the consumer, there's absolutely no change in the UX, except now you pass on composite evidence rather than just simple evidence. And this composite evidence is then processed by a composite evidence handler, which invokes a parser, depending on the media type that is coming in. Could be a CMW collection, could be an EAT submod-based EAT, doesn't matter. The right parsers invoke, the collection is tokenized, and then each of the tokens, each of the sub-evidence is then looked up into a routing table, which then invokes the right component verifier clients to do the communication with the downstream verifier. When the downstream verifier is finished with the appraisal, the component verifier client is responsible for translating the attestation result format, which could be anything, into an ER appraisal claim set, and pass it back to the CE handler, which will then take care of accumulating all these ER appraisal in their associated submods, and then sign the final ER and send it back to the client. So this is, in fact, the dual, if you want, of the RATSD scheme that I presented a couple of slides before. Next, please. So yeah, a couple of takeaways for you. I'd like to really to listen to these 2 points. So one is, you are a technology, yes, you are. If you're looking to prototype RAT-based solution, I warmly encourage you to take a look into the repo, the org, but because you might find what you need already off the shelf. Or if you're not lucky, you could at least find a foundation on which to build. And also, well, this is not written there, but we are a very small community, but we are also very active and very responsive. So I think the experience, we can guarantee a good experience in the interaction with us. Sorry. And the second takeaway, maybe it's not for this full of people, but if you know a student, maybe your sons and daughters or whatever, a relative that is looking to explore the RISE architecture through hands-on learning, we also run a mentorship program sponsored by the Linux Foundation. So anyone applying and successfully applying to this will get a stipend from the, will get some money for the 3 months they spend with us getting Veraison better. So yeah, that's it. I think the next one is the last one, because we are proud alcoholics or whatever. Yeah, we hope to see you soon.
So thank you very much. Any questions? So while we're waiting to see if there any questions come up, one from me. What's your, in long term, do you see Veraison as a, I'll call it production quality verifier? So something that you can, you know, if you are operating a verifier commercially, you see it in that role?
Yes, definitely. And to this, I forgot to mention the fact that Oracle Cloud is already shipping Veraison in their confidential computing offer.
Okay, so there's actually
an
at-scale deployment today.
There is,
Cool.
as we speak, yeah.
Okay, thank you.